Hi everyone. In this video you're going to learn about polar coordinates and equations. So coordinate systems are just a way to define a point in space. And the coordinate system that you're most familiar with is the rectangular, also called the Cartesian coordinate plane. So in the rectangular coordinate plane, a point is identified by an ordered pair, x comma y, where, if we were to plot a point, let's say that point is -2, 3, then the x coordinate is -2 and the y coordinate is 3. And so to plot that point, you always start at the origin, and of course you move along your x-axis first. So, we would start at the origin and then we would go left to -2, and then you move along your y-axis. So because the y coordinate is 3, we would then go up 3. So like the -2, 3 tells us to go left 2, up 3 from the origin. And of course we know that the point would end up right here. Okay, well, this is not the only way that we can define a point in two-dimensional space. So another way that we can define a point in two-dimensional space is with polar coordinates. So with polar coordinates, a point in the plane is defined by a pair of numbers, okay, but instead of x coordinate and y coordinate, those numbers are represented by r and theta. Theta measures the angle between the positive x-axis, so here's our positive x-axis, which is also called the polar axis, and a ray that passes through the point. So if this is the point that we are plotting, then theta is the angle created. So this would be theta. So theta measures the angle between the positive x-axis and a ray that passes through the point. Now r measures the directed distance from the pole, which is the origin, to the point. Okay, so this is r. R is just the distance from the pole, which is the origin, to the point. Okay, so to represent this point, the coordinates would be 2, pi over 4, where r equals 2 and theta equals pi over 4. Okay, now that you understand basically what polar coordinates are and how we define a point in the polar coordinate system, the next thing that you'll want to be able to do is convert between those two coordinate systems. So you can convert from polar back to rectangular or from rectangular to polar. Okay, so to do that, you need to know these relationships. Okay, if given r comma theta, then we know that x, the x coordinate in the rectangular coordinate system, equals r times cosine theta, and the y coordinate would equal r times sine theta. Okay, so let's look at example number 1, because here we're going to convert the following polar points back to rectangular points. Okay, so remember, in polar coordinate, r is 4 and theta is 2 pi over 3. Okay, so converting here is actually pretty easy because we know x equals r times cosine theta. So my x coordinate would just equal 4 times cosine of 2 pi over 3. Okay, well remember, cosine at 2 pi over 3 is negative 1/2. So then if I multiply 4 times negative 1/2, I get negative 2. Okay, and then I know that my y coordinate is going to equal r, which is 4, times sine of theta. So times sine of 2 pi over 3. Okay, and then we know sine at 2 pi over 3 from our unit circle is going to equal square root of 3 over 2. And so again, if I multiply straight across, I get 2 square root of 3. So my rectangular coordinates are negative 2, comma, 2 square root of 3. Okay, let's look at one more example. So in example B, r is square root of 5 and theta is pi over 6. So again, we know the x coordinate is going to equal square root of 5 times cosine of pi over 6. Okay, cosine of pi over 6 is square root of 3 over 2. Well, if we multiply straight across, we're going to get square root of 15 over 2. Okay, the y coordinate is going to equal r, which is square root of 5, times sine of pi over 6. And sine at pi over 6 is equal to 1/2. So again, if we multiply straight across, we get square root of 5 over 2. So my rectangular coordinates would be square root of 15 over 2, comma, square root of 5 over 2. Okay, so that's pretty easy. Okay, now we can also convert from rectangular to polar. So to do this, you need to know that r squared would equal x squared plus y squared. And you guys, that's just Pythagorean theorem, okay? And also that tangent of theta is equal to y divided by x. Okay, let's look at some examples. So let's say we want to convert, the rectangular coordinates, negative 2, 2 square root of 3, to polar coordinates. Okay, the first thing we're going to start with is the fact that r squared equals x squared plus y squared. And remember, we have an x value and a y value. So we're just going to plug those in. So we'll have negative 2 squared plus 2 square root of 3 squared. Okay, so we'll get r squared equals 4 plus, well, 2 square root of 3 squared would become 4 times 3, which equals 12. So we get r squared equals 16. And then we're going to square root both sides. And so we're going to end up with r equals 4. Okay, and notice that our rectangular coordinates, that this point would actually be in quadrant 2. That's important when we find theta, okay? So remember that tangent of theta equals y divided by x. So if I take 2 square root of 3 and divide it by negative 2, that's going to equal negative square root of 3. Well then, if I use my inverse trig function, I can solve for theta. So we know that inverse tangent of negative square root of 3 would equal theta. Well, because our rectangular coordinates, that point is in quadrant 2, if we're trying to, identify a point in quadrant 2, then you want to think to quadrant 2. Okay, tangent would be negative square root of 3 at 2 pi over 3, okay, which is in quadrant 2. Okay, so our polar coordinates here are 4, comma 2 pi over 3. Okay, let's look at our next example. Okay, so notice, again, I always like to start with the r squared equals x squared plus y squared. So if I do that, we're going to have r squared equals 25 plus 25, or r squared equals 50. We're going to square root both sides, and we're going to get r equals, and if I simplify my radical, I'll end up with 5 square root of 2. Okay, and then remember we know that tangent of theta equals y over x, so that will equal negative 1. And then if we use our inverse, but notice that this point is in quadrant 4. So the angle in quadrant 4 where tangent equals negative 1 is 7 pi over 4. Alright, so my polar coordinates are 5 square root of 2, which is r, comma 7 pi over 4. Okay, moving on. Now, we can also convert equations. Okay, so just like converting points from one system to another, we can also convert equations. So in example 3, these equations are rectangular because they're in the form y equals something in terms of x. So to convert these to polar equations, we're still using those relationships that we learned when we were converting coordinates. So these are super important to know. Okay, so remember how we learned that y equals r times sine theta? Well, if 4 is equal to y, then we can substitute 4 in place of y, and we get 4 equals r times sine theta. And when we write our polar equations, we like to solve for r. So it's usually r is equal to something in terms of theta. Okay, so if I were to solve this for r, I would just divide by sine theta, and we would get sorry, trying to scroll down. Can't seem to grab that right at the edge. Okay, so anyway, we get r equals 4 divided by sine theta. Okay, let's look at y equals 3x plus 2. So again, we are going to replace y with r times sine theta, and we're going to replace x with r times cosine theta. So this is what we would end up with. Okay, then we just want to solve this for r. So in order to solve for r, I would subtract the 3r cosine theta, bring it over to the left side. And then we can factor out r on the left side. So that'll leave sine theta minus 3 cosine theta equals 2. And then we can just divide, and we'll get r equals 2 divided by sine theta minus 3 times cosine theta. And that would be our polar equation. All right, so let's look at some examples where we convert the polar equations back to rectangular equations. Okay, so in this case, what I'm going to do is, so like in example A, we have r equals -3 times secant theta. Well, remember in our two relationships where we know x equals r times cosine theta and y equals r times sine theta, we kind of want to be able to use those. So notice if I divide by secant theta on each side, I get r divided by secant theta equals -3. And remember how secant theta is the reciprocal of cosine? So 1 over secant theta actually equals cosine theta. So our left side would become r times cosine theta, basically just using a trig identity. And then once we have r times cosine theta, we know r times cosine theta equals x. So we get x equals -3. And that is our rectangular equation. Okay, now let's look at B for a minute. So we have r equals 4 divided by 1 plus 2 times cosine theta. So the first thing I'm going to do is multiply by 1 plus 2 cosine theta on each side. So we'll have r times 1 plus 2 cosine theta equals 4. Okay, at least we don't have a fraction anymore. Okay, then I'm noticing if I distribute the r, I'll have r times cosine theta, and we know that equals x. Okay, so if we distribute r, we'll get r plus 2 times r times cosine theta equals 4. And then at least I know I can replace r cosine theta with x. Okay, so this will be r plus 2x equals 4. Okay, well, you're probably thinking, well, what do we do now? Well, we could subtract the 2x and then remember the relationship r squared equals x squared plus y squared? Well, if we can change this r to an r squared, then we can replace it with x squared plus y squared. And we could do that as long as we square both sides. Okay, so now we have r squared equals, and if I were to FOIL out the 4 minus 2x squared, that would give me 16 minus 16x plus 4x squared. Okay. Then I can replace r squared with x squared plus y squared. And then all I have to do is just solve for y. So then I can just subtract the x squared, and we'll get y squared equals 16 minus 16x plus 3x squared. And then we can just square root both sides. And so we get y equals positive and negative square root of 16 minus 16x plus 3x squared. And that would be the rectangular equation for the given polar equation. Okay, so it is super important that you guys understand, you know, how to plot points in a polar coordinate system, and that the polar coordinates are in the form r comma theta. And then it is super important that you remember these relationships, okay? X equals r times cosine theta, y equals r times sine theta, r squared equals x squared plus y squared, and tangent theta equals y over x. Okay, so we'll definitely practice this some in class. And as always, thank you for watching, and have a good night.